In the previous lesson, we learned about evaluating trigonometric functions, and then we had the opportunity to solve for missing parts of the right triangle using the trig functions. Now, in that particular lesson, we were looking mostly for missing sides. If we were ever looking for a missing angle, we had enough information with the other two angles to use our geometric principles to come up with a missing angle. Now, in this particular lesson, we are going to work on solving a missing angle using trig and using our calculator. So having your calculator handy for this lesson will be good. So if we think back to a number of different things that we've done in past mathematics, we have used what we call an inverse multiple times. And if we think about it, if we said 2x equals to 16, we could divide by 2, or we could multiply both sides times 1/2. Now, what we're keying in on here is this. What did this do? The 1/2 and the 2. Well, the 1/2 and the 2 together gave us a 1x. And of course, that's going to leave us 8 on that side. But this is the part that we want to talk about. This 1/2 is the reciprocal of 2, and they cancel each other out, leaving 1. But really what we did here is we took the original value of 2 and we multiplied it times its inverse. So the 1/2 was the multiplicative inverse, leaving us, so the 1/2 and the 2 inverses of each other, when multiplied together, leave us the identity, which is the 1. And of course, we tend not to write the identity. You've seen this in another way as well. If you recall back to matrices, if we were trying to solve a matrix equation, we multiplied both sides by the matrix inverse. And the inverse and its matrix left us with the identity matrix. And of course, just like before, the identity matrix acts like the number 1, so we don't write it. And we've effectively eliminated that term from the left-hand side. Well, we're now going to use that same concept, the idea that each trig function has an inverse. So if we use that inverse, that creates the identity, or it eliminates it altogether. It's kind of like a 1, so it cancels each other out. So we're going to use that idea of an inverse in this particular unit or lesson. So if we go back to the notes, you can see here we have a little table of inverse functions. Now, generally speaking, we informally refer to them as, the inverse of sine or the inverse of cosine. From a technical standpoint, you may hear teachers or textbooks refer to these inverse functions as the arc sine or the arc cosine or the arc tangent. So just be aware that that's just referring to inverse functions of trigonometric functions. So keep that in mind. So we'll use this inverse function as a way to cancel out trig functions. Now what this is going to do for us, and if you look at example problem number 1, we have the tangent of A equals 0.8391. What we're really looking to do is figure out what does the measure of angle A equal. So we need to get that A value alone, and since it represents an angle measure, we write that as the measure of angle A like we did in geometry. So we're going to use the arctan, or the inverse tangent function, to eliminate that. And of course, when multiplied times the tangent function, that gives us the identity function, which basically leaves A by itself. Now, if we do the inverse on one side, we also have to do the inverse on the other side. And this is where our calculator is going to come in handy. To do an inverse function, we can go to our calculator. And if we come into the calculator part and we go to the trig button again, we can see that we have not only the 6 trig functions, but we also have the inverse functions. And so we can just select, we can also select the inverse functions and then just put in the corresponding value and hit enter, and that should give us the angle for A, and in this case it's 40 degrees. So what I want you to do is, for sample problem number 1, just get in the habit of using your calculator for the inverse function to strip away the trig function from each angle measure and come up with the individual angle measures in sample problem 1. Okay, and so I'll just go ahead and work through this with you really quickly. And so I know that if I take the inverse function of both sides, I'm going to say the tangent of -1 times the tangent of B equals the inverse tan of 0.7536. Then these are going to cancel each other out, and the measure of angle B is going to end up equaling 37 degrees. And so that's in effect what you would do for each one of these. And so if you did that for part B and you did that for part C, you would end up with the measure of angle C is equal to the inverse cosine 0.3907, and the measure of angle C would end up being 67 degrees. Theta, and notice we didn't say the measure of angle theta. Since we're using the Greek letter here, we tend to just leave the measure of that angle letter value off of there. So theta equals the inverse sine, and so theta would actually end up equaling 46 degrees in this case. Alright, so that's a good quick introduction to inverse functions, and we'll see how we're going to use that in more advanced trig problems in the next couple of videos.